On our agenda for tonight, I'm just going to talk a little bit about me. We're going to compare the 2019 to 2020 rubric, kind of compare the two of them. We're going to look at two student samples that the College Board released. These two samples happen to be Python examples, so I thought that it would be a good introduction for us. And then we'll kind of talk about our restaurant project, which is an exemplar that you can find inside of the PopViz teacher resources. All right, so a little bit about me. I'm a high school computer science teacher out in Livingston, New Jersey. So this is my pandemic classroom right now. As you can see, I'm wearing my mask. I've got my projector over there. So I have a Master's of Arts in Teaching Secondary Education Mathematics. I also have a Master's of Science in Digital Forensics and Cybersecurity. I also have a Bachelor's of Science in Computer Information Systems from William Patterson and John Jay College of Criminal Justice. These are New Jersey, New York City colleges and universities. I also teach as an adjunct professor at Kean University. All right, so last year, which feels like a really long time ago, I was a reader for AP Computer Science Principles. So it's kind of interesting, I have to say, the experience of, being a teacher and teaching AP Computer Science Principles, and then getting to see the submissions from all around the world that students make. And the other thing is that, again, like in Principles, as we know, there are all sorts of different languages that you could be submitting your task in. So it's also interesting to kind of see the different perspectives that students have when they submit their performance tasks. So now we're going to talk about the 2019-2020 rubric comparison. So as Jane said, I would say that the rigor level between 2019 and prior to that and what it is right now, I think is much higher than it was before. I think the College Board probably made those changes just because, CSP has now been around for, I think, 3 or 4 years or so. So last year, they had a pilot. They had a couple of schools. I actually piloted a version of the new curriculum, but I made sure that my students took the previous version of the performance test just because I wanted to make sure that they would get college credit. Again, a little bit later on the presentation, we're going to go through some of the submissions that some of the students who did the pilot submitted and got scored by the College Board. So a couple of new changes kind of going forward with APCSP is that there is no longer any audio narration allowed in the video. Now, I can tell you from my experience as a reader, people did actually have audio narration. Sometimes it was kind of strange because I'm not sure if it was intentional or not, but there'd be kind of like background noise, etc. The reason why I think they made this change in particular is because they didn't want to bias the readers who are reading it. Again, the submissions are not even just in the United States. They're coming from all around the world. So I think, again, they didn't want readers to kind of get impressions from whoever was submitting things. And so they wanted to be kind of basing it on the written responses versus any kind of audio narration. So that's one really kind of big change. Second up, previously, before, you had to demonstrate the running of the program and kind of look at least one feature. And going forward, the College Board is now looking for something very specific. So they're looking for input, they're looking for output, and they're also looking for exactly how the program functions. So they're looking for a little bit more than it was before, kind of like looking for some kind of interactivity, looking for something to change inside of the program. As the user puts in different inputs, they have to get some kind of different outputs. All right, other changes in the rubric. So development process, previously, it asks you to describe the incremental and iterative development process, describe the challenges and opportunities. And now they've kind of gotten rid of that requirement there, so you don't have to describe the development process. We're going to get on to kind of, I think, the more complicated part of the new changes here. These are the required programming concepts. So previously, they asked for mathematical or logical operators and one or more of the following abstractions, things like procedures, parameters, lists, APIs, and libraries. And going forward, Now they're looking for specifically lists, or in Python, dictionaries are also fine too, and procedures with at least one parameter. So that's like very specific that they're looking for. And so again, I think they're trying to make students kind of like think about when they write their functions to have kind of like more functionality than they had before. Because if you look back over here, this is kind of saying one or more. It's not being very specific. So you could just get away with, let's say, just having a program with just lists, not necessarily having functions, but now we're going with functions with at least one parameter. And you have to have a list as well. So again, it's almost like double the previous programming requirements there. The student's program had to include one or more algorithm that included sequence, selection, and iteration. And now going forward, again, a little bit different. Now they're requiring all three algorithms there. So the student has to demonstrate sequence, selection, and iteration, all three, not just one. So again, rigor level kind of like going up there. All right, so student samples. So again, the College Board, this is on the College Board website. They released, I think it was like 6 samples or so in different programming languages. I've kind of plucked out the Python ones because our course is in Python here. So the scoring criteria, row 1 is the program purpose and function, and they're looking for very specific things here. So the video has to demonstrate, again, input, functionality, output. The written response has to describe the overall purpose of the program, describe what functionality of the program is demonstrated in the video, and describe the input and output of the program demonstrated in the video. So again, College Board has kind of gone away from kind of audio, talking about it, which I certainly saw inside of some of the submissions that I graded, and now they just want students to write it out. All right, row 2 is data abstraction. So in data abstraction, they're looking for 2 program code segments, one that shows how the data has been stored in the list or another kind of collection data type like a dictionary, and one that shows the data in this program list being used as part of fulfilling the program's overall purpose. So in other words here, the student can't just create a list just kind of like out there in the air and not actually use it. It has to contribute to the overall functionality that they originally described. Also identify the name of the variable of the list/dictionary collection data type, and describe what the data contained in the list is representing in the program. So again, they're kind of looking for a lot of documentation about what exactly the code is doing. So row 3 is managing complexity. So the written response includes a program code segment that shows a list being used to manage the complexity of the program. So again, this kind of goes back to what exactly is the purpose of this collection data type and how is it being used. And second part here is explain how the named selected list manages complexity by explaining why the code could not be written or how it could be written differently without using that data structure. So again, now it's asking from what it was before. Now it's asking, again, very specific, why did you decide to use it this way? All right, row 4 is procedural abstraction. So again, they're looking for functions again, but this time it's required versus before you could either have chosen either list or procedure, etc. Written response includes 2 program code segments, one showing the procedure, and again, this is the really important part here. It has to have at least one parameter that has an effect on the functionality of the procedure. So that's really kind of important, and we'll kind of talk about this later on inside of the webinar. This kind of takes some thought from the student in terms of writing the procedure. What exactly is this procedure going to do? And because of this requirement of one parameter there, like what information am I going to take in? And then how am I going to process that in kind of a meaningful way? So again, this new version of the performance task, I feel really requires a lot of kind of thinking, kind of like some backward design, which I'll talk about in a little bit, on the student's part in order to meet all of this new criteria here. All right, and then of course, College Board really into asking the student to describe exactly what was going on in their mind when they created that procedure there. All right, algorithm implementation. So again, now you have to include all three, sequence selection and iteration, and also explain in detail how the identified algorithm works in enough detail that someone else could recreate it. So again, College Board looking for very, 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 very specific things. And again, I think they're trying to get students to kind of explain more of their work and have it be more meaningful. All right, and finally, row 6 is testing. So they want the students to describe 2 calls to the selected procedure. So they call it see what happens. Each call must pass a different argument, which is also really kind of important here. So again, more kind of like backwards thinking here. If it's going to pass different arguments, the function has to behave in different ways. So again, you have to give a lot of thought here in terms of like what exactly this program is going to do. Describe the conditions being tested by each call to procedure, and then identify the results of each call. All right, so again, these are the pilot samples that the College Board released. Again, kind of like some things I think to keep in mind in terms of what the College Board ultimately released here. So if you think about it, I think most places around the United States had a shutdown in March. So I know my school, I think we shut down probably third week of March or so. So, if you think about it, students were kind of in the middle of perhaps they started the performance task at that point, or they might have done the performance task completely on their own during this kind of remote environment. So those are kind of like some things to keep in mind in terms of the samples that they got. Of course, they're in comparison to the overall submissions that the College Board got. Again, this is a pilot, so we don't know exactly how many students actually submitted these samples here. So again, they released, how many samples is this? I think this is about 10 samples or so. G and I are Python examples here. The other interesting thing is that the one that got full credit was the MIT App Inventor one. They actually, in these 10 samples, they gave examples in all different programming languages. There's even a Java one, which actually didn't do very well. But we'll look at G and I right now. So G and I didn't do very well. So they got 2 and 2. And so again, the people who submitted this into the College Board, this wasn't rated on 1 to 5 like how it is, because this is just the pilot. So these students were not getting credit for what they submitted. So row I kind of took a screenshot of the running program. Again, the running program, you can kind of click on your own and kind of see what it looks like on the College Board website. The student here is trying to make a kind of RPG game, kind of like an adventure game, I think was his or her or their intention here. They put in their name, they're kind of giving a description of what their character is going to become, they're giving some attributes, etc. And so the student kind of wrote inside of row 1 when they submitted it, the program my partner and I wrote addresses the issue of making an RPG character. Though there are many RPG character creators out there, they can be complicated and difficult to use. Our program is very straightforward with lots of room for customizability in order to allow the easy creation of an RPG character for either a beginner or seasoned veteran. Okay, so that looks somewhat reasonable, but at first glance, kind of like, I guess the reader in me is thinking like, I'm not sure if you're writing everything that you're supposed to be writing here. So again, the College Board is looking for very specific things here. So this first row here got 0 points. They didn't earn the points for this row here. So first off, the video demonstrates the running program. Okay, that's good. The response states the program's purpose is to address the issue of making an RPG character in a way that's very straightforward. Okay. But then The response does not describe the functionality described in the video. So I think here the student didn't give enough detail. I mean, I think they were trying, but they didn't quite get enough detail there. And in addition, they missed the criteria of describing the input and output of the program demonstrated in the video. So, again, when I read the paragraph there, I thought the student was trying to get to those points, and maybe the student thought that what they were writing was implied, especially since that they're running the program. They might think, okay, it's implied that I'm giving the input and output. But again, the College Board is looking for students to very specifically state these things and how they fulfill the rubric. All right, so going on to row 2 here. So row 2 here, as you can see, the student has a dictionary. They've got a function called start roll, which looks like it's kind of like rolling die, printing out some stats here. So the student kind of like added these annotations here of like changing values to kind of document their code a little bit. In row 2, College Board, when they graded this, the response earned the point for the row, meeting all of the criteria. So that code segment was good from the College Board side here. So row 3, this is what the student wrote in row 3 here. So the data in the list stats represents the stats of the player's character. Okay, the list manages the complexity by allowing all of the stats of the character to be in one area, so they can be easily changed. Okay. Furthermore, this dictionary will allow it to be easier to export everything to a document, as all player stats are in one central location, and it's taking much less formatting. The College Board, the reader here, gave full credit for this. The response earned the points a row because the student talked about the list and explained how the list worked. All right, next up we've got row 4 here. So row 4, I'm going, uh-oh, when I look at this here. So the student submitted a while loop here and kind of put in some conditionals, but there's a little bit of a problem here because the code segment is not a student-developed procedure. So I'm not really quite sure what happened here. Again, when students submit to the College Board, the reader doesn't see the overall code that they came up with. So I'm not clear if maybe somewhere in the student's code there was a procedure. Maybe they got confused, but at any rate, all they put was a while loop. So that's definitely not a student-developed procedure. So they did not earn points for that. All right, 3C, an algorithm that was developed that includes sequencing, selection, and iteration is the race selection algorithm. The algorithm loops until a proper race is entered, and using an if-else statement, it selects which race was entered. It then uses sequencing to append values. Okay. And this allows the character to choose the race that they wanted. Okay, so this is what the reader says here. The response did not earn the points for this row because it did not meet either of the criteria. So the response includes a program segment of a student-developed algorithm that appears to, this is where I said, I feel like the reader is really kind of giving the student the benefit of the doubt here. So it appears to include selection, iteration, etc. Even though this algorithm is not included in a procedure at the parameter, it would still be considered. So again, I feel like College Board really going out of their way to give people the benefit of the doubt. Now, this is why it was disqualified. It says, however, because the loop control variable looper1 is initialized to 1 and would be changed to 2, this loop is trivial. So this is kind of the important point here. So again, I think College Board giving people the benefit of the doubt, but when they see enough, I think they've had enough. And so when they saw that this loop was trivial and it wasn't really doing all that much, they just disqualified it. Testing the program, student says tested many cases. I wish I could erase on my smartboard a little faster, but unfortunately I'm using my pen tip here. We tried entering numbers as well as differently capitalized words, etc. to test it. da 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 da. Okay, however, our loop and lower program work fine. We also tried entering other things, including lawful, neutral, chaotic, and it worked perfectly well. All right, student not doing too well here. All right, response did not earn the point for this row since there's not a procedure with parameters. So couldn't really test that because they didn't have parameters there. All right, this is the second Python example here. If you were to run this, this is like a very bare bones example here. It's kind of generating random numbers. When I saw this, I was actually just very curious to see how this was scored, just because I thought it was very bare bones. So just looking at row 1, I thought, again, the student wrote very minimally here. The video shows the program being used to calculate random integers based on the integer input. This addresses the issue of having to calculate random numbers for various purposes. And now there's an easy tool to do this. And again, student did not earn points for this row. Although I have to say I was really surprised about this part here. The response met only 5 out of the 6 criteria. So actually the student was really close. So what they didn't, the reason why they didn't get credit here was the response describes the input shown in the video as based on an integer input. However, there's no description in the response of the output demonstrated in the video. Calculating random numbers is not the same as displaying these numbers as output from the program. So again, they're being very specific here, I think, in terms of what they're looking for. So again, when you're with your students trying to give them advice about writing the responses here, I would say they have to make sure that they hit every single point. All right, so this is row 2. So good news here, we do have a function that's good, and we even have a list here. Oh, even better. Okay, so we're looking okay here. We even have a loop. Okay, so let's see what we got here. The response earned the points for this row, meeting all of the criteria here. Okay, that's good. And this is row 3. So student says this procedure consolidates the generation of random numbers into a simple function. This accomplishes its task by generating numbers and returning a list. This is the list the program needs to print. Uh-oh. All right, so the response did not meet either criteria. Okay, so the response includes a program segment that shows a list. However, the list does not manage the complexity of the program. It is irrelevant. Okay, that's the first part here. The response attempts to explain how the list manages complexity by generating multiple numbers, because without lists, each number would be printed individually. However, the random values could easily be printed as they are generated, so the list does not manage the complexity of the program. So again, I think the College Board, again, is trying to eliminate some of not very rigorous submissions in the past here. All right. They go on and they write, one case was inputting the number 5 and the other was inputting 10. During one, only 5 numbers was generated, and the other 10 are generated. The expected result is a list, 5 random integers and 10 random integers. And the reader says they earned points for this. The response earned the point for the row because they created that procedure there. It took in the parameter, so that met the criteria there. However, for row 5, the response did not meet the criteria because the response met only one of the 2. So again, very specific here. This was the sequencing iteration. The response includes a program segment that includes sequencing and iteration. However, it does not explain what the algorithm does and does not explain how the algorithm works so that it can be recreated. So again, that part is, as I mentioned before, is new this year. And again, it's kind of like forcing the student to document exactly what they're doing. All right, and lastly, row 6, the response did not earn the points because it only met 2 of the criteria. The response describes 2 calls to the selected procedure with 2 different parameters, and both were valid. However, since both were greater than 1, the calls did not evoke different code segments in the algorithm to execute. So again, this is where I was saying that students, when they develop their function to fit this criteria, really have to give it some thought in terms of how to meet this criteria here. All right, so now we'll kind of talk a little bit about, again, one of our exemplars, the restaurant project. This is a demo of the restaurant app that we created, kind of, again, as an exemplar that you can find inside of the teacher resources. So I'm just going to play it right now. Again, videos are supposed to be about 1 minute long or so. I would say that in order to demonstrate the functionality that you want to give the College Board for the readers to get full marks on that, I would say that your students should be submitting videos that are about a minute. There's also a size requirement, a size limitation, that file sizes can't be above a certain length. Generally speaking, I wouldn't say that the College Board is going to say, okay, it's more than a minute, we're going to disqualify this. Again, they're just kind of looking for about a minute or so, demonstrating the functionality of input, output, and the whatever functionality the student says that they were going to do inside of the program. All right, so I'm just going to demonstrate the running of the program right now. So as you can see, there's it starts off with a menu, and now it's kind of asking things like, would you like to add toppings? Yes. I'm going to move that out of the way here. And so there are different choices here depending on the menu. You've got beverages, etc. And I think we're making some more choices here. There's a dessert menu over there. And it's back to the main menu now. And now we're doing checkout. So we're checking out. And now we have, are you interested in any special offers? And the user says yes. And so because the user says yes, they get a free drink, which happens to be a Coca-Cola. So some advice that I would give students, because I think that, again, this rigor level of this performance test is much higher than it was in the past. And you have to think about all those different criteria that the College Board is now giving. I think a really good way to kind of get students thinking about this is actually to work backwards. Again, CSP is actually based on UBD, the Wiggins Understanding by Design. So I feel this strategy here, and this is directly from the course description here. One strategy just to kind of teach them in general is to work backwards. So working backwards, trace a possible solution back to the starting point. Starting point, again, would be the criteria specifically that the College Board is looking for. And so for my students, what I kind of like tell them to do, I kind of give them choices to draw flow charts. I'm not very finicky about the flow charts. I really kind of want them to be able to map out their ideas. And again, I think it's really important for this project to kind of map out where they're going with things. So I've showed them things like, here are 3 basic shapes, and this is like how you can kind of use it. So rectangles like a process, kind of like a diamond shape is a decision, and that oval shape is like a terminator. Again, you could actually not necessarily use all of the symbols here. And again, my flowchart, when I kind of ask them to do things, I don't necessarily ask them to do every single thing, especially when they're going to get up to this part here. Now, kind of going to this task here, I drew a flowchart, which might be useful, again, to kind of share with your students in terms of kind of like building out ideas about fulfilling this rubric, this new rubric that the College Board has here. Again, to kind of like explain to students, I would start off with, what is the functionality of your program? Like, what are you kind of going for? And kind of preceding that, I would say you want to kind of ideate and kind of like think about what kind of program can I write that would be interesting to me being the student, by the way, and fulfills the College Board's criteria. I think at the end of the day, the College Board's trying to get students to create projects that they'd be interested in, give them enough time, give them enough classroom time to work on it, and then, again, kind of like fulfilling a specific specification here. Also kind of thinking, what is the purpose of the program? So that's kind of the idea stage. Now, once they're up to the functionality, then the student has to kind of think about more things. They have to think about input. They also have to think about output now. They have to think about eventually example inputs because they have to show that demonstrating running. And then they also have to show example outputs. Now, again, what's new here and what's making this a little bit more complex than it used to be, they have to have some kind of data type, some kind of collection data type. Here I put a list here. And the specific criteria that the student has to meet is how's the data being stored, how's it being used, and also how does it manage the complexity of the program, and again, kind of explaining how the program couldn't be written if it didn't have this collection type. So all of these things here, again, I think a good way would be to have students kind of like map this out, kind of like think about all these moving parts before kind of diving into coding. Also, they have to think about functions with a parameter. So again, that's very specific there. Has to be student developed. If they're writing Python, that should not be a problem. In other languages that I will remain nameless, that could be a problem. But in Python, I think in general, students will ultimately be using their own procedures. So that's a good thing. And very importantly, how does it contribute to the program's functionality? So all of these things here. And last but not least, of course, we have to have that algorithm containing sequencing, selection, and iteration, and explaining in detail so someone else could recreate it. So feel free, again, we've shared the Google slide of this presentation. You know, again, like I tell students when they want to draw flowcharts, they could use like OneNote. Some of them have like pens and kind of like two-in-one laptops, so they can use like OneNote. But you know, sometimes I tell them actually the easiest thing these days could be just write it on a piece of paper. I think that's very flexible, and I think the math teacher in me would say pencil and paper is very useful. All right, so now going on to our restaurant project here. So kind of like mapping out our restaurant project, and I have to say that when I was trying to write a program for this restaurant project program to fulfill the criteria, when I first kind of started delving into it, I started to realize what I was saying before about the backwards design. I was thinking to myself, wait, how do I fulfill the criteria of collections? Okay, well, I'm going to make a dictionary. I'm going to have sandwiches and prices, perhaps. Then I kind of thought to myself, okay, wait, I need that function that's passing in information that's going to do something very specific. It's going to do different things based on whatever is being passed in. Again, that's a very specific thing that the College Board is looking for. So to accomplish that, I came up with a pretty simple algorithm there. So depending on how much they spent, if they spent more than $10, they would get a free Coke. Else, if they had to order 10 or less, they would just get a $1 coupon off for a future order there. And so, let me just go back here. What's the functionality here in a restaurant project? The overall functionality is to order sandwiches, beverages, dessert, and then kind of check out. And then the examples here are kind of like what I was showing in the video before, just kind of giving different inputs and then getting the output based on what they ordered, the total, etc. All right. So again, you can find these resources in the teacher resource section of our curriculum over here. All right, bye everybody.